Hi everyone, welcome to my channel. Subscribe to my channel for more videos and click the bell icon for further notifications. A question has been picked from the year 2024. It says, for the differential equation, x times log x to the base e times dy, that is equal to log x to the base e minus y times dx. Option A says degree of the given differential equation is 1. Option B, it says it's a homogeneous differential equation. Option C says solution is 2y times log x to the base e plus a, that is equal to log x to the base e whole square, where a is an arbitrary constant. That means simply a constant. Option D talks about solution again. That is 2y times log x to the base e plus a, that is equal to log of log x to the base e, where a is an arbitrary constant. We need to choose the right option. So option 1 says a and c only. Option 2 tells a, b, c. Option 3 talks about ABD. Option 4 says A and D. So whenever we come across this kind of question, always differential equations means it's better to rewrite them as dy over dx. Then only we'll get an idea. So here in the question, dy is already there. We'll try to bring this dx on the other side so that becomes dy over dx. On the right hand side, they have given log x to the base e minus y. So for that, we are going to bring this term on the right hand side. So that becomes the denominator. So now this is our first order derivative. For this, the power is 1. That means degree is 1. Option A is matching nicely. So we can pick option A. Now, what we have to do means, in order to identify the type of differential equation, we need to simplify further. We will try to simplify this. What we are going to do means, we are going to divide individual term with the denominator x log x to the base e. Now, this and this get cancelled. We can move this on the other side. It becomes y over x log x to the base e. And on the right hand side, we have got 1 over x. I assume you are familiar with linear differential equation. That is nothing but whenever the differential equation in this pattern appears, that is said to be linear differential equation. So now our question also is matching with this pattern because we have got first order derivative and then y is there along with a function of x is there, that is equal to another function of x. So that means we can follow this pattern. So whenever it appears like this, in order to solve, we need to find integrating factor first, that is nothing but e power integral p dx. Then the solution becomes y times integrating factor, that is equal to our q right hand side. Along with that, integrating factor also will be considering for integration, and then finally we'll be getting our required answer. Suppose if it appears in this pattern, dx over dy means that we will be tried in a different way. As of now, our question is matching in this pattern. So these are the steps which has to be followed in our question now. So let's follow this. So as of now, our coefficient of y is our p. So here p is nothing but 1 over x log x to the base e. So we'll try now our e power integral of p dx. That is nothing but e power integral 1 over x log x to the base e dx. Whenever the question is complicated, we'll be using our substitution method. So we are going to try that. Let's assume u to be our log x to the base e. Log x to the base e is nothing but our natural log that we know already. In our previous videos, we talked about this. Okay, now the derivative of log x is 1 over x dx. We are able to match with the question nicely because 1 over x dx is du. So e power integral du and our log x is simply u. So 1 over u. Integral of 1 over u is nothing but log u. Now this is nothing but simply u. Why? Because e and log are inverse functions, so they are getting cancelled nicely. So finally we are getting our p to be u. I'm sorry, integrating factor to be our u. So u is nothing but log x to the base e. So this only has to be multiplied on both the sides to get our solution. So y times integrating factor, and here on our right hand side, q is nothing but 1 over x. So here we will be getting 1 over x log x to the base c dx, and then we need to integrate this. Again, this one is a complicated function. We'll try substitution method again. Assume t to be log x to the base c. Differentiation of this is 1 over x dx. Now we can replace everything as t dt because this is t, remaining things are all dt. On our left hand side, we are having our value as usual. Integral of t is t square over 2 plus c, and here we are getting log x to the base c whole square over 2 plus c. In order to match with the option, we are going to multiply with 2 on both the sides so that the denominator will get cancelled. So 2y log x to the base c, here log x to the base c the whole square plus 2c. Now what we are going to do means we are going to bring this 2c on the left hand side. So that becomes 2y log x to the base c minus 2c, that is equal to log x to the base c the whole square. This 2c is nothing but a. Simply a constant we can assume with any alphabet in order to match with the option. I am assuming that to be a. Now if you cross check with the options, 2y log x to the base e, and then we are getting our plus a. Yeah, yes. If you bring this on the other side, that becomes plus a. Because our assumption only, we can assume a to be minus 2c. Arbitrary constant means we can assume negative constant or positive constant, our assumption only. So in order to match with the option, I am writing our a to be minus 2c. This is assumed as a, so now it's matching with the option C. So A and C only matches with the solution. So that is the right option. Hope you are able to follow. Thanks for watching. Happy mathing.